Our next topic is chi-square test. It is also known as goodness of fit. For goodness of fit, we use this test. See the introduction of this test. The chi-square test is an important test amongst the several tests of significance developed by statistician. It was developed by Carl Pearson in 1900. Chi-square test is a non-parametric test not based on any assumption or distribution of any variable. This statistical test follows a specific distribution known as chi-square distribution. In general, the test was used to measure the difference between what is observed and what is expected according to an assumed hypothesis is called chi-square test. So, mainly we use this test to measure the differences between observed and expected values assumed by hypothesis is called chi-square test. Okay, this is also known as a non-parametric test. This test is based on frequencies and not on parameters like mean and standard deviation. See this one? You see, F test, T test depend upon the T test depend upon mean differences and then next P test, F test, next test F test, that is depend upon variances, but variances means standard deviations, but this test does not depend like the previous two tests. It does not depends on mean, standard deviation. That it depends only is based on the frequencies. So it is said to be non-parametric test. The test is used for testing hypothesis and is not useful for estimation. Only testing hypothesis, not useful for estimation. If degree of freedom greater than 2, distribution is bell-shaped. If degree of freedom is 2, distribution is L-shaped with maximum ordinate at 0. If degree of freedom less than 2, distribution L-shaped with infinite ordinate at the origin. In case of binomial distribution, the degree of freedom is n-1. In case of Poisson distribution, the degree of freedom is n-2. In case of in case of normal distribution, the degrees of freedom n-3. You change this one. So, for three distributions, binomial, Poisson and normal distributions, we let different values for degree of freedom. This test can be used in goodness of fit of distributions. Second one, this test can be used in test of independence of attributes. Attributes means qualities. Okay. Test of goodness of fit of distributions. This test enables us to see how well does the assumed theoretical distribution such as binomial distribution, Poisson distribution or normal distribution fit to the observed data. The chi-square test formula we are going to use. The chi-square test formula for goodness of fit is chi-square is equal to sigma O minus E whole square by E. Here O is observed frequency and E equal to expected frequency. See the properties. The first one, chi-square distribution curve is not symmetrical. Lies entirely in the first quadrant. Next, chi-square distribution depends only on degree of freedom. Third one, as the degree of freedom increases, chi-square distribution approaches to a normal distribution. Then chi-square varies from 0 to infinity. These are the properties. See one more, another two also there. According to the four properties, the fifth one is mean of distribution is equal to degree of freedom. Here you observe more. Mean of distribution is equal to degree of freedom. Variance is equal to twice of degrees of freedom in the distribution. These are the properties, 6 properties. Mainly observe mean of distribution is equal to degree of freedom. variance is equal to twice of the degrees of freedom in the distribution. Then applications. This test is used to compare with a value or to compare two or more value in groups, always using categorical data. This test is used in genetic analysis in biology. Now we see the problems. Mainly you remember the formula for chi-square. Okay. See the problem. The number of automobile accidents per week in a certain community are as follows: 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. Are these frequencies in argument with the belief that accident conditions were the same during this 10-week period? Per week we have given 10 weeks accidents data here. Per week, for example, for first week 12 accidents are there in particular place or particular area. In second week the accident number is 8. In third week 20. Like that 10 weeks data given here. Are these frequencies in agreement with the belief that accident conditions were the same during this 10-week period? ఈ 10-week period accident conditions same గా ఇట్లాగే ఉంటాయా అని అడుగుతాను. See the solution. Expected frequency of accidents each week. Expected means మనం సెకండ్ యూనిట్లో చూసినాం. Expected means mean. Just mean. What is expected value? Sigma of these values, sigma xi by n. Sigma xi by n. Sigma xi by n. What is this? Sigma xi by n. 100 by 10. 100 by 10. What is 100 by 10? See here, ma. What is 100 by 10? 10. So first we see the expected values. Now in data we have given observed frequency and the value expected frequency we found it. So these frequencies are in given problem, in given data, given frequencies are known as observed frequencies. Here we found another frequency which is called expected frequency. So expected frequencies are EI. Observed frequencies are OI. Okay ma? Now frame the table. Observed frequency given in the table. OI. Expected frequency. We found it. EI. For each one EI is same here. It is not given in the problem. Okay. Next column OI minus EI. Observed frequency minus expected frequency. What is this? 12 minus 10 is 2. 8 minus 10 is minus 2. Similarly, the remaining values. Then, let squares of these values. OI minus EI whole square. What is EI minus OI minus EI whole square? 4 square values. 4, 4, 100 like this. By EI and by 10. Here, OI minus EI whole square means 2 square by 10. 4 by 10, that is equal to 0.4. Then again minus 2 whole square means 4. 4 by 10 is 0.4. Then 10 square, 0 minus EI square. 10 square by 10 and 100 by 10 which is 10. Like that the remaining values. Now we take the sum of these values 26.6 which is sigma OI minus EI whole square by EI values. Okay. Now let the null hypothesis H0, that is observed equal to expected. The accident conditions were the same during the 10-week period. In P test we take mu n is equal to mu 2. Mean conditions. Difference of means another. Then for F test sigma square, sigma 1 square is equal to sigma 2 square. Then S1 square is equal to S2 square. Difference between variances anna. But here difference between these two, observed and expected, both are same under null hypothesis. Alternate hypothesis means it is oppose H0. O is not equal to E. What is that? The accident conditions are different. Same ante H0. Different means opposite of same. కాబట్టి H naught is the accident conditions are different during the 10-week period. Next, third point, level of significance. It is not given in the data. So, take it as alpha, 0.055%. Here n is equal to 10 observations. Now, degree of freedom is n minus 1, which is 9. From chi-square tables, for this alpha value and the degree of freedom 9, from tables chi-square tabulated is 16.9. This is 16.9. Okay, ma? Then the test statistics means chi-square calculated value. That is equal to, use the formula sigma OI minus EI square by EI is equal to 26.6 from table. You observe, ma, here no doubt, calculated value is 26 and tabulated value is 16. So, no doubt, calculated value greater than tabulated value. So, what is our conclusion? Chi-square calculated greater than chi-square tabulated. So, null hypothesis H naught is rejected. What is H naught? H naught rejected means H1 accepted. H1 accepted. What is that? The accident conditions are different during the 10-week period. Now we see the next problem. A sample analysis of examination results of 500 students was made. It was found that 220 students has failed. 170 had secured third class. 90 were placed in second class and 20 got a first class. Do these figures commensurate with the general examination result, which is the ratio of 4:3:2:1 for various categories respectively. You see, what total we have given 500 students. Okay, it was found that 220 has failed and failed candidates 220. Next, 170 third class, 90 second class, 20 got first class. And these are the frequencies, observed frequencies. What is the first one? 220, second one 170, third one 90 and fourth one is 20. Okay, these are the observed frequencies. Do these figures result which is in the ratio of 4:3:2:1 for various categories respectively. Okay, ma?